So this video is for the periodic table of elements. It is going to be split up into two parts just because it's pretty heavy. There's a lot of stuff we have to know, a couple trends and those kind of things. But this first day, what we're going to do is we're going to talk about atomic symbols so that we can further understand atomic symbols. We're going to see about how elements are organized, and we're going to look at some information contained within a periodic table. These elements are not just randomly sorted. They're not just thrown at a dartboard and said, well, that's where it's going to go. There is a lot of method to the madness, so let's jump in. So symbols, scientists today use abbreviations to represent each of the 118 elements on the periodic table. The abbreviation is called its symbol. Every state has a symbol as well. Think about Pennsylvania. Very infrequently do we actually call the state Pennsylvania. We all just call it PA because it's way too long of a state to say it in its entirety. Excuse me. So that's what you would put in an envelope. Same thing here. Copper, that's kind of what pennies are made out of. Not entirely anymore. But copper is abbreviated or has a symbol of Cu. Oxygen is O, uranium is U. There's quite a few, obviously 118 of them. So we're going to talk about a couple examples and then you're going to catch on to the trend and be good to go. So atomic symbols are alike in the following ways. First, the symbol has one or two letters. If it has only one letter, or if it has two, the first letter is capitalized. Okay, so just like a sentence, whether you're writing a big, nice, complex sentence or the short little sentence like the dog barked, you still want to capitalize that first letter. If the symbol does have two letters, though, you want to keep that second letter lowercase. Okay, so notice on that last slide it was copper and it was big C, little u. Okay, and there's no period at the end of the symbol. It's just one or two letters. No dot, no hyphen, no stars, nothing weird like that. Okay, so we see here, this is oxygen, and its symbol is O. And then there's some other numbers on there that we're going to either talk about or we have talked about. Just as a brief recap or preview, depending on where you are in your lessons, the 8 up top here, that's the atomic number. So that's how many protons, how many electrons, and how many neutrons are present in the oxygen element. So this one has 8 protons, 8 electrons, and 8 neutrons. Down here is the mass number, or the atomic mass, depending on which book you're looking at. What this number is equal to, it's the addition of protons plus neutrons. So if there's 8 protons and 8 neutrons, that would equal 16. I know that's not quite 16, but it's pretty close. Okay, so if you want to know exactly why it's not 16, come up and ask me. If not, we're just going to save that for high school. So a scientist named Mendeleev, fun name, his first name was Dmitri, noticed that some elements were similar to one another, just like anything. So he designed the first chart to show similarities. You might have talked about this last year in life science. Okay, think about a grocery store. When you go into the grocery store, they keep all the cold things together. And they keep all the cereals together. And they keep all of the Oreo cookies together. And they keep all of the pastas together. They do this so it's organized, so that you can show similarities. Mendeleev right here, with his illegal on school property cigarette, he was organizing things. He was keeping things that were gases all together. And he was keeping things that were all reactive together. So he really was ahead of his time. He began by making cards for each of the elements. Think of flashcards, that exact same thing. He wrote down the element name and what he knew about it. He might have known the atomic number, or how many protons were present. Or maybe he was able to find the mass of it, the number of protons plus the number of neutrons. So he wrote down anything he could. He then organized them based on its mass. He was just simply saying, all right, you're really light and you're really heavy. You go off to the left and you go off to the right. Done and done. Okay, but it was a lot more complicated than that. But here's what his first little idea looked like. He did form the first periodic table. It's an arrangement of elements by increasing atomic number. But notice here there's a little bit of an issue. Okay, your scientific definition, periodic table, is by atomic number. Mendeleev, he did it by mass. Okay, so somewhere along the lines, we needed to switch gears here. Excuse me. He actually got really, really close, though. These are pretty close to the correct order. So you're going to be able to pick up on trends. He has some gaps here because he knew there had to be some. We jumped from 40 to 48 atomic mass units, how heavy the atom is. He knew that there was most likely something in here because nowhere else was there that big of a jump. Normally it jumps by like here it's 6, here it's only 3. So he knew that 8 was a pretty big jump. So his table did change over time, as I kind of told you on the last slide. As new elements were discovered, he also found that the atom's properties were related more to its atomic number than to its mass. So that's what I was talking about on that last slide. Mendeleev, all he had to work with, or one of the more important things he had to work with, was the mass. He could very easily find a teeny tiny scale and find a teeny tiny atom and put it on the teeny tiny scale. And then he could look at the number and call it a day. As we got more advanced and as we learned about electrons, and if you're going to chemistry in high school, valence electrons, he learned that, or other scientists learned that that was more important than just how heavy something is. Okay, it's just like a fat dog. A fat dog is still cute, even if it's heavy. Same thing here. Okay, so there's just a little recall. The atomic number tells you the number of protons. So that turned out to be more important than the mass itself. So elements are arranged into rows. Rows go back and forth left to right. Okay, so when you're reading this slide, you're reading left to right, right here. This is a row of words. This is a row of words. This is a row of words, okay? So just to give you an idea what a row is. The first two rows, the 2 rows at the bottom are actually too long to properly fit into the periodic table, but they should be where the notes show. I'm going to show you this on the next slide. So what you're picturing and what I have on my poster in 2 different places in my classroom, over by the air conditioning and then up front by the clock, actually isn't 100% correct. So here's what it typically looks like, just in case you're not near one of those 2 posters. You have all sorts of letters, all sorts of numbers. You're going to kind of learn some trends, but it's okay if you don't have this memorized till the end of the day today. I guess I won't hurt your grade too bad. But in high school, you will need to know this a little bit more in depth. So these 2 rows, as we move left to right, the atomic number increases. Okay, so you can see here, this number is going up. I'm going to click off that arrow. We go 55, 56, 57, 72. We'll figure out why, because here's 71. But let's look at this row. 37, 38, 39, 40, 41, 42, blah, 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 54. That's just saying as we move this way, we are adding 1 proton each time. And when we're adding 1 proton, we are also adding 1 neutron. We are also adding 1 electron. So from Ti to V, we added 1 electron, 1 proton, 1 neutron. We can tell because our atomic number increased by just 1. So if I wanted to give you a little bit of a math problem here, I totally could. Let's use these 2 for instance. If I said, how many more protons does oxygen have than carbon? That's going to test a couple things here. Is 1, can you find oxygen? 2, can you find carbon? And 3, can you do a little bit of easy math? So you would tell me that oxygen has 2 more protons than carbon right here, because we're just going from 6 to 8. That's an increase of 2. Easy peasy lemon squeezy. Another thing we need to look at here is that these 2 bottom rows, should actually be up here. Notice the little asterisks. Okay, so this pink row should line up right here with LA. Notice how it goes 57, 58, behind here's 59, 60, 61, blah, 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 blah. Okay, then we start at 72, and here's 71. So this is what it actually should look like. Okay, but notice how much smaller this is than the last slide. It's very difficult because we have to allow space for all of this junk here in the middle. So that's why we keep it nice and simple when we push those guys down to the bottom, so that we can get a little bit more detail rather than having it all stretched out like this. So looking at a symbol, and on your notes how this is set up is you're going to have to write down every single word that's about to pop up on your screen. Okay, so I'm just giving you a warning right now. You have to fill it in on the lines just like I have it here. So your element name is going to be most likely somewhere on your periodic table. Not every periodic table provides the name. Some of them expect you to be super geniuses and have them all memorized. I won't do that to you. That's super mean. I might make you think or know a couple of them, like oxygen O, super easy, okay? But some of them are difficult, like potassium. Potassium is in bananas. It prevents cramps. It does all kinds of good stuff for your body. Its symbol is K. Potassium. K. It doesn't make sense. So there's definitely some that you're going to learn naturally, and there's others you're not going to know any reason why it's there, and that's perfectly fine. So the next thing you got to look for is your atomic number. Reminder, that's your number of protons. Okay, protons are the positive part of the cell. So in this case, oxygen has 8 protons. That also means that oxygen has 8 neutrons. And that also means that oxygen has 8 electrons. Okay, so just keep that in mind. That number actually represents 3 separate things. It's not just the number of protons. The symbol is your big letter. Every single periodic table of elements is going to give you that big letter. It's going to give you any sort of letter. It might give you Cu for copper, Au for gold. It might give you Mg for magnesium, H for hydrogen, He for helium, all sorts of things. So you're going to kind of, like I just did, you're going to be able to rattle off a couple of them. You're going to learn them, but I don't expect you to memorize the whole table. That would be just cruel and unusual. And finally, down here at the bottom, that's going to be your atomic mass. That's approximately equal to the number of protons plus neutrons. I have that little squiggly line because you notice here the math's not adding up. 8 plus 8 does not equal 15.99. It should be 16. And like I mentioned before, there is a reason why it's not 16. I don't want to confuse you with a new word and a new term. If you are a curious little guy or little girl out here, then let's get this situated. Come up to me. I will happily explain why this number is not 16, but for right now, just pretend it's close. Okay, it's super duper close. So let's look at one more just to practice. So notice we have one of these arrows popping in early. Stinking arrow. So up here we have our atomic number again. Okay, things are a little bit different in order this time. So your atomic number, that's your number of proteins, is up top. So uranium has 92 protons, 92 electrons, and 92 neutrons. Your symbol is still here in the middle. It's your big letter. Uranium's nice and easy. Its letter is U. The element name is right here. It's nice and easy to read, uranium. And finally, the atomic mass. Again, that number is the number of protons plus the number of neutrons. Approximately. Okay, if you did some math here, this one totally doesn't line up. The atomic mass of uranium should be 184. This is not working math-wise at all. That's why this little squiggly line is here. Okay, I don't want you to stress. I'm not going to be that mean and give you ones that don't line up. Okay, I would give you one like oxygen. What is the atomic mass of oxygen? You're going to add 8 plus 8. It's close enough. 15.999 and 16 are close. If you did this one, you'd get it wrong. We don't want to do that. Okay, I'm not that mean. And last but not least, the position of an element in a periodic table can tell you many properties of the elements. So properties change as we move from left to right. Blah, 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 number of electrons change. So that's what we're really looking at here. So I gave you a printout of the periodic table. Go ahead and flip to that at this point real quick. All the way to the left. Okay, put up your hands, find your left. Your left, they have 1 extra electron. They want to get rid of it. They don't like it, it's no good. It would be like you having $1 extra dollar in your pocket and you're like, man, I just cannot have an odd number of dollars. I can't do it. I need to have an even number. So you give away $1. When they give away that $1 though, it's super explosive. Okay, we've seen videos of it catching on fire and stuff. Now move the whole way to the right. Those all the way to the right are called noble gases, and we're going to talk about those more later on. Those have 8 electrons on the outside. They have an even perfect number. Your magic number you're going to learn in high school is 8. Every single electron wants to have 8. Oh, atom wants to have 8 electrons. So we can use these patterns and properties to predict things. We're going to talk about this more in part 2 of the periodic table. I don't want to confuse you at all. The biggest, most important thing that I need you to get from today's notes is right here. Okay, the different symbols and what each of these things on this square mean so that you can start to interpret a periodic table. So go back to Google Classroom or look up at the whiteboard, figure out what you need to do next. If you have any questions at all, please raise your hand and I'll be around to help you.